We've talked about ways to deal with a function that is the product of two functions, and we also have ways to deal with a function that is the quotient of two functions, or a rational function. So something of the form y equals f of x over g of x. And just to shorten the notation a little bit, I'm going to rewrite this as u over v. Now if we wanted to take the derivative is equal to the derivative of the numerator, in this case u prime, times the denominator, v, minus the numerator, in this case u, times the derivative of the denominator, v prime, all over the denominator squared. Right, this is called the quotient rule. Now hopefully you can see why I do the product rule the way I do. The product rule, as a reminder, is if you have a function that's the product of two functions, u and v, then the derivative is equal to u prime v plus u v prime. Right, so very similar in an order sense are the numerator of the quotient rule and the product rule. Right? One, the difference is subtraction. And then the quotient rule has a denominator that's v squared. Let's look at an example. Let's say we have a function, so y equals 3x squared minus 1 over 2x cubed plus 5x squared plus 7. Well, the derivative of this by the quotient rule is equal to the derivative of the numerator, so in this case it would be 6x times the denominator, or v, so 2x cubed plus 5x squared plus 7, minus the numerator, in this case 3x squared minus 1, times the derivative of the denominator. Right, the derivative of the denominator in this case would be 6x squared plus 10x. Right, so that's this huge numerator divided by the denominator squared. So in this case it would be 2x cubed plus 5x squared plus 7 quantity squared. And again, I want to emphasize that unless there's a good reason for you to simplify, this is the expression for the denominator. Don't spend your time simplifying unless there's a good reason to do it. This is acceptable as an answer.